Hello, today is Fourier Friday, so we're doing Fourier series. We have this problem over here. We have to prove that the function of x is even, and this statement is true. Then its Fourier series on the interval from minus pi to pi is an expansion by cosines of multiple angles, and similar to a different statement for if function is odd. Let's begin by reviewing it with function is even. F of x is equal to f of minus x, and f of pi over 2 plus x is equal to negative f pi over 2 minus x. Okay, let's begin by checking out the sign-related coefficients for Fourier series, because we're trying to prove about the fact that expansion is solely consisted of the coefficients with cosines per se, yeah? So there's going to be 1 over pi times definite integral from a negative pi to pi of f of x times sine of nx times dx. Now, if we were to look at this thing over here and assign it some function temporarily, let's call it f1 x. And if we were to plug in minus x, is gonna be f minus x times sine of negative nx. Now, f of x is even, so it's just gonna be f of x, and sine function is odd, so we can pull the minus sign outside like this. So essentially, f1 of x is an odd function, so the definite integral from negative pi to pi is going to be just equal to 0. Cool, now let's review the other coefficients related to cosine. I have to prove that they are not going to be present for n that is for n that isn't odd. F of x times cosine of n times x dx. Now, let's return to this statement. You can see how it really looks like some kind of odd function. And in fact, if we were to say that there's a function g of x that is equal to f of pi over 2 plus x, then the above statement can be written as g of x equals to negative g of negative x. In other words, we know that g of x equals f of pi over 2 plus x is an odd function. That would mean that we can do a substitution here and see how it goes. Let's say that the substitution u equals to... Actually, what's going to be handy here, we need to get, instead of x, we need to get x plus pi over 2. So that's going to be u equals x minus pi over 2, pi over 2. Now, thing is, we can delete this minus pi here and just multiply this expression by 2, because on the contrary to the sine one, this function is even. Definite integral is going to be equal to this too. So now if we were to do the substitution, it can be 2 over pi times definite integral from negative pi over 2 to pi over 2 of g of u plus pi over 2. No, just g of u. That's good be if it was f still, but x is going to be equal to u plus pi over 2, and f of u plus pi over 2 is just g of u, as we have defined. And we're going to have a cosine of nu plus n pi over 2 du. Now, if we were to look at this expression over here, if we take cosine of nu plus n pi over 2 and say that... Okay, let me think for a second. I'm having a brain freeze there. Okay, I have unfreezed. If we were to say that n is a multiple of 2, it's safe to say that cosine is gonna be nu plus some okay, I'm having a brain freeze again. It's gonna be this times -1 to the power of n. I think that's it actually. Except I have definitely messed up here. N over 2. Say we take n equals 2, for example. It's gonna be 1 here, it's gonna be pi here, and it checks out. Okay, this is gonna be the cosine function after simplification, and let's add g of u back. So, thing is, as this is most definitely gonna be an odd function, because cosine is gonna be an even function, and g of u is gonna be an odd function, and this will evaluate to 0. So we can literally just bring out this outside. 2 over pi, definite integral from -pi over 2 to pi over 2 with respect to u. It's going to be just 0, given n is again a multiple of 2. And if it's not a multiple of 2, it is going to become some sort of sine function instead. I'm not going to write it down because it's really a similar thought process, but instead you're going to get an even function. So it's a valid coefficient in the series. So we have kind of proved it, because any functions per se are used in the series for cosine, and it's gonna work only for n that isn't a multiple of 2. Now let's review the other part. If function f of x is odd, and this statement is true instead, okay, let's see. F of x is odd, so f of x is equal to negative f of negative x. And we know that f of pi over 2 plus x is equal to f pi over 2 minus x. This expansion is by signs. Okay, let's begin. We can define another function just like last time. Say that it's, that g of x is f of pi over 2 plus x. Then g is just going to be an even function. G of x is equal to g of negative x. Cool. Now let's find the related constants. A of n equals to 1 over pi. Definite integral f of x cosine of nx dx from negative pi to pi. Now, we know that it's an odd function, cosine is an even function, so it's just gonna be always 0. Let's look at b of n equals to 1. Okay, let's write it down as an integral from 0 to pi instantly. 2 over pi times definite integral from 0 to pi of f of x times sine of nx dx, because both sine and f of x are odd functions, so their product is going to be an even function, so I just pulled out the 2 here. Cool, now we can again do a substitution. It's going to be 2 over pi. I substitute u equals to x minus pi over 2. And therefore x is equal to u plus pi over 2. Okay, so from negative pi over 2 to pi over 2. Next, f of x plus pi over 2 is just g of x, as we have defined it. So g of u. And sine of nx is gonna become sine of nu plus np over 2 with respect to u. Now we just need to find when this is gonna be even, when this is gonna be an odd function. So for n, that is not a multiple of 2, g is an even function, and for okay, it went back. That was weird. Okay, I'm confused, but sure. So where were we? Okay, here's the point. Sorry, I cleared the entire thing accidentally. Not sure how. Okay, so for n that is in a multiple of 2, it's gonna become cosine, which is also an even function. So it will have a non-zero coefficient. And for n that is a multiple of 2, it's gonna stay the sine function. And since any type of sine function is gonna be just an odd function, and g of x is an even function, the product is gonna be odd, and therefore the definite integral is gonna be a 0. So we have proved this. That's it for today. Bye.